Hello, my name is Matthew Hagan. I'm going to demonstrate some of the results from my camera calibration. So I'm going to show the calibration results, which we have parameters focal length, which is the focal length of the X and the Y. They're usually around the same, however in digital systems there's some slight deviation. These are the tolerance parameters. The principal point is a description of the center of an image. Our skew has to do with the shear strain on a pixel, which in this case it's 0. Our distortion is an equation that is used to model whether there is radial distortion, either negative or positive, which is a pincushion or a barrel presentation. And so let's demonstrate how the system computes the extrinsic properties of an image. So we're going to compute, so I have several images already loaded in. I'm just going to select one of them, image 40, it's a .tif. So we're going to keep the parameters the same. So the image is coming over here. So the first thing we do is we're going to want to click each one of these corners, and we always make sure that we click the origin first. Then once we click the last corner, we have to be careful that we land right on the edges or the points, at least within 5, otherwise we can add distortion into the system. So there's 9 in the X direction, squares, there's 7 in the Y, and each one is around 27 millimeters from what I measured manually. And this is giving us our translational vector, and if we go through, we can see our delta x and our delta y. So based on the system, our origin is at -82 in the x direction, -119 in the y direction, and 457 millimeters in the z direction, which the z direction is coming right at us. Camera calibrations are very important and used for vision systems. The next part of this system I would like to analyze is an optimization GUI that I developed. So we are going to run this, which I was given some raw input data and some output data. And so by picking some initial angles for phi, theta, and psi, we're going to use the input data and the output data to develop a model of the system and create that. We're going to iterate upon that model with a sum squared error function so that we can get a calibrated output matrix that models our known output. So when I run the calibration, I have 20 iterations shown. It went through more, but these are just the ones that I modeled and used a spline fit. So our system error went all the way down to 0.000003, which is extremely small, so on the 6th decimal, which if you see, these 6 decimals all model perfectly with our original output data. So if I want to select one of our input points, which is 1, 2, and 3, we can generate the output. And the output is -2.230442, which is the exact same for the first. This corresponds to this row right here. And each value, all the way down to 6 decimals, is perfectly modeled. Thank you for your time. That's it.